in 2.3, continued from the other day, I'm going to show you guys today how to do synthetic division. So synthetic division is, yes, an easier way to divide polynomials, but before you get angry with me about not teaching you this before, I just want to mention that it only works if the divisor is in this form right here, x minus is in this form right here, x minus k, which all that means to you is that it only works if, first of all, if the divisor is linear. Probably want to add this. If it is linear, that means the highest power of the x is 1. And I also want to mention that in front of the x is a 1. So in other words, the coefficient of the x, the coefficient equals 1. This is the only time it works. And it's pretty cool. It works quick, it's fast, it's easy, but it only works in very, very certain situations. So this is what you need to do. For example, you have this polynomial x to the fourth minus 5x cubed plus 2x minus 3, and you are going to divide it by x plus 4. First of all, is this a linear polynomial? It is linear, x to the first power, and the coefficient in front of x is a 1. So notice what I do. If it's x plus 4 out in front, you put the opposite. You put a negative 4 out front. And then these numbers right here, the 1, the negative 5, the 0, the 2, the negative 3, any idea where those things came from?
From the
Go ahead, Marcus.
middle.
Yeah, they're the coefficients of all the terms in that polynomial. So this 1 comes from the 1 in front of x to the fourth power. The negative 5 comes from the negative 5 that's in front of x cubed. There's no x squared. There is no x squared in that polynomial. Therefore, we say there are 0 x squareds. You must have the placeholders in when you're using synthetic division. The 2 comes from the 2 in front of the x, and then there's a negative 3 at the end. Okay? This is what you do. Take this 1 to begin with. I'm going to delete here. Take this 1 and you bring it down. You just write, oh, by the way, you just draw this big, it's kind of like a big gigantic L with a really long leg on it. You bring the 1 down. And then you take this negative 4 and you multiply it by 1. What's negative 4 times 1? Negative 4. So I wrote negative 4 down. You combine these two, a negative 5 and a negative 4, together give you negative 9. And now you multiply negative 4 by negative 9. Negative 4 times negative 9 is a positive 36. You add together the 0 and the 36. You get 36. Now you take negative 4 and you multiply it by 36. You get negative 144. You combine 2 and negative 144, you get negative 142. Then you take negative 4 and you multiply it by negative 142, you get a positive 568. That number goes right here. You combine negative 3 and positive 568, you get positive 565. This number right here, the very last number, is the remainder. That's the remainder. So your answer is, now this is the thing, how do you know what powers do each one of these things go to? Well, if you are starting with an x to the fourth power, your quotient is going to be x to the power, one less power, so it's going to be x to the third power. If this first term in our polynomial was an x to the sixth power, your answer is going to be x to the fifth power. All right, so your answer here is going to be a 1 x cubed, a minus 9x squared. Then this 36 means plus 36x. And then we have a minus 42, and then the number at the end is 565 divided by this thing right here, divided by x plus 4. What do you think? Not much? Easy? Alright. Another example. Try this one.
Okay.
X to the fifth minus x to the fourth minus 6x cubed plus 2x squared minus x minus 10 divided by x plus 2. So there's a 1 in front of the x to the fifth power. There's a negative 1 in front of the fourth power, x to the fourth power. Then there's a negative 6, a positive 2, a negative 1, and then a negative 10. So no missing terms. We have a fifth power, a fourth power, a third, a second, a 1, and a 0 power. So I have to put no placeholders in, no zeros in, and I just line them up. I line up my 1, my negative 1, negative 6, 2, negative 1, negative 10. X plus 2 means that you use what kind of a number instead of plus 2?
Negative.
Use a negative 2, use the opposite, so you put that out front. And then here we go. Take this first 1 right here, you bring it down. You do negative 2 times 1 is negative 2, so it goes right here. You combine a negative 1 and a negative 2 to get negative 3. You do negative 2 times negative 3 to get a positive 6. You add them together, you get nothing. You get 0. Now you take negative 2 times 0, you get 0. You add together 2 and 0, you get 2. Then you multiply negative 2 times 2, you get negative 4. You combine the negative 1 and the negative 4 to get negative 5. Then you do negative 2 times negative 5, it gets you a positive 10. You add it with the negative 10, you get 0. What does this 0 mean? That means that there is no remainder. It's always just the last number is the remainder? Yep, the last number is the remainder. If you get a 0 here, that's going to mean something in a few minutes. So our quotient then is, remember we started with an x to the fifth power up here? So that means that your quotient is going to be 1 degree less than that. So it's going to be a 1. This 1 goes with this thing right here, this term, 1x to the fourth, negative 3x cubed. There's no x squared, so I don't even need to write it down. So I didn't write that down in my answer. We go on to the 2, you get 2x. Bring down your minus 5. Yes?
I get this.
Me too.
That's gonna be 3.
If I'm going to go out on a limb here and say that it might actually be fun.
It's cinematic. No.
Alright, let's try the next one. I knew you guys would like this, but I remember too that it only works in very certain situations, so it would be great if it worked all the time. But alright, let's try this example. I left an empty example here. It's not done here now, so let's try it together. Alright, x minus 5. X minus 5, so what goes out in front of your big gigantic L? Positive 5. No. Do this. And then we need to write down all the coefficients. So the first number is going to be a 3. And then we have a negative 17. Do I need to put in any zeros in here? Do I need any placeholders?
No.
Nope.
You don't need any placeholders this time. You put down a 15, and then the last number is going to be a negative 25. All right, the first thing that you pull down is the 3. So I put the 3 right here. So it's 5 times 3 is 15. You add negative 17 and 15, you get negative 2. You multiply 5 and negative 2, you get negative 10. Add 15 and negative 10, you get 5. Multiply 5 times 5, you get 25. You combine negative 25 and 25, you get 0. Which means to you that there is no remainder. And also you write your quotient as, we started with a cubed, which means we are ending with a squared. 3x squared minus 2x plus 5. That is your quotient. Nice, huh? Yes, very easy. Three points on the test. Okay, let's go on. The remainder theorem.
Oh.
Not hard. We're going to use synthetic division to do all of this. So the remainder theorem says this. If a polynomial f of x is divided by x minus k, the remainder is r, which is equal to the value of the function at that k value.
Do I have to write all that?
If you want to. Example, use the remainder theorem to evaluate f of x. Here's f of x, 4x squared minus 10x minus 21, when x is equal to 5. Now this time, I am telling you that x is 5, which means if you were to write this as a linear factor, you would write it like this. It would be x minus 5. Okay? Now, if it's written as x minus 5, you know that you need to take the opposite of that. But in this case, I already gave you the x value. I already gave you the 5. This, right, x minus 5, means that x is equal to 5. So no need, in this case, to switch the value. It's already switched for you because I told you that x equals 5. So you put a 5 out front. You write down the 4, the negative 10, and the negative 21. 4, negative 10, negative 21. Alright, I bring the 4 down. You with me here? Bring the 4 down. 5 times 4 is 20. You add together a negative 10 and a positive 20. You get positive 10. 5 times 10 is 50. You add negative 21 and 50, you get 29. And according to the remainder theorem that we just talked about here, what it really means is that this 29 is our remainder. That means that if I were to plug a 5 into this function, replace all the x's in the function with a 5, my answer would be 29. That's what the remainder theorem says. Now, if you were to graph this, 4x squared minus 10x minus 21, the point 529 would obviously fall on the graph too. So it means that f of 5 is equal to 29. The factor theorem. A polynomial f of x has a factor, x minus k, if and only if, when you plug in that value of k, if you get 0. So in other words, that means if you get a remainder of 0, it means that it is in fact a factor of that polynomial. Yes?
What did you say about
X, this right here?
Yeah.
It says x minus k.
Okay.
No. X minus k. Alright, if x minus 5 is a factor of x cubed plus 4x squared minus 27x minus 90, you need to use synthetic division to find the other linear factors and then name the zeros. Sounds complicated, but I don't think it's going to be. right, if x minus 5 is a factor, so if if x minus 5 is a factor, you guys know that when you're setting up the synthetic division problem, you always put the opposite of that out in front. So the opposite of a negative 5 is a positive 5. That's what goes out front, a positive 5. And then you line up the coefficients. So you put a 5 out here. Line up the coefficients. The coefficients are 1, 4, negative 27, and negative 90. So I lined them up. 1, 4, negative 27, negative 90. You bring the 1 down. 5 times 1 is 5. Add together the 4 and the 5, you get 9. 5 times 9 is 45. Add together negative 27 and 45, you get 18. 5 times 18 is 90. Add together negative 90 and 90, you get 0. What does that tell us?
No remainder.
What'd you say?
No remainder.
No remainder. Yep. And then in this case, it means that x minus 5 is a factor. Okay? Since I have a remainder of 0, it means that x minus 5 is a factor. My answer here is going to be 1x squared plus 9x plus 18. X squared plus 9x plus 18. Now, what would you do in a situation like this to figure out what the zeros are or what the factors are? What did I do? How did I come up with this x plus 6 and x plus 3? You're looking for two numbers that multiply to give you 18, and when you add them together, you get a positive 9. So x plus 6 and x plus 3 are your other two factors. So once you got it to look like this, then it became a pretty easy algebra problem for you. So the three factors are these two things, x plus 6 and x plus 3, which I wrote down right here. And then the last factor is x minus 5. Okay, so what are the zeros? These are the factors, which means the zeros are what, guys? Negative 6?
The opposite.
The opposites, yes. Negative 3 and positive 5. All right, now try x plus 6 with 2x cubed plus 7x squared minus 42x minus 72. Again, no zeros. You don't have to add in any placeholders, any zero placeholders. So you write down the 2, the 7, the negative 42, or negative 42 and the negative 72. And your job is to attempt to find out whether or not x plus 6 is a 0. If x plus 6 is a 0, that means we would get 0 as a remainder. Now I already did the math. We got a 0. So it is a factor. It says x plus 6. So you write down negative 6 out front. Should I walk you through the synthetic division, or do you feel like you know how to do it? Know how to do it? You end up with the remainder of 0.
This down first. I touched the pepper the morning it grabbed my eye.
Alright, so you end up with a remainder of 0. Now, we have 2x squared minus 5x minus 12 as our quotient. Yeah?
I have a question. For the factors, it says x minus 4. Why does on the bottom it says for the 0 it says negative 4? Should that be positive?
Yeah, it should be. It says positive, so you really want to know. Yes, nice catch, sorry. Yes, it's supposed to be supposed to be a positive 4, not a negative 4, thank you. All right, so we end up with 2x squared minus 5x minus 12, and we need to factor this now. This is a little bit harder to factor. Why is it a little bit harder to factor? There's a coefficient, there's a 2 in front. So, you guys, we haven't spent a ton of time factoring quadratics that have a coefficient other than 1 in front of the x squared. So, but I know this is what I'm trying to get. I'm trying to get 2x squared. I'm trying to get a negative 12 at the end. So what are the only two numbers that I can multiply to get me a 2? 1 and 2. So that's why I have a 2x up front here. I have a 2x here, and then I have a 1x right here. And I also know that these last numbers have to multiply to give me a negative 12. So that could be any combination of numbers. It could be a 2 and a 6, it could be a 3 and a 4, it could be a 1 and a 12. So I probably did trial and error, and this is what I came up with. I came up with the fact that 3 and negative 4 we're going to multiply to give me negative 12, which of course that works great. 2x times x gets me the 2x squared. The 3 and the negative 4 get me negative 12, but the problem is we need the middle terms to add up to a negative 5x. We need them to be a negative 5x. So that means this. If I multiply the 2x and the negative 4, what is 2x times negative 4?
Negative.
It's a negative 8x. And then these other middle terms here, 3 and x, what's 3 times x? 3x. Now if I combine these two, a negative 8x and a positive 3x, what do I get? You get a negative 5x. Isn't that what we wanted? Now, if you didn't get that, then you have to switch things around. You got to try different numbers, maybe move your positive and your negative signs to different values. So 2x plus 3 works, x minus 4 works. That means that your factors are, remember this factor works, so one of your factors is x plus 6. Another one is x minus 4, and then your other factor is 2x plus 3. Now, if it's x plus 6, you know your 0 is negative 6. If it's x minus 4, you know your 0 is positive 4. And then this thing right here, 2x plus 3. How did I end up with negative 3 over 2? What did I do? How did I get that? What do I do to this to come up with a 0 of negative 3 over 2? Go ahead, Marcus. Side equal to 0. Do 2x plus 3 is equal to 0. I subtract 3 from each side. So 2x is equal to negative 3. I divide both sides by 2. I end up with negative 3 over 2. That's where that last 0 came from. That's what zeros mean. You're putting each one of these factors equal to 0 individually and figuring out what the x values are. In this case, it's a negative 3 over 2. All right, one more example. We're going to try it together, and then I'm going to be done talking for the hour. Are x plus 2 and x minus 1 factors of 2x cubed plus x squared minus 5x plus 2? All right, let's start with the x plus 2. Let's figure out whether or not x plus 2 is a factor of that polynomial. What do? Synthetic division for sure. But if it's x plus 2, what goes out front? A negative 2. So I put a negative 2 out front, draw your big gigantic L, write down all the coefficients here. Now, do I have any zeros? Do I need to put any zeros for placeholders? No. So I put a 2 here, a 1 here, a negative 5, and a 2. I bring the 2 down. I get 2. Negative 2 times 2 is negative 4. Combine the 1 and negative 4 to get you negative 3. Multiply negative 2 times negative 3, you get 6. Add negative 5 and 6, you get 1. Negative 2 times 1 is negative 2. Add these together, you get no remainder. So my question is this: is x plus 2 a factor?
Yes.
It is. This quotient right here leaves me with 2x to what power? Squared. We started with a 2x cubed. That means here we have a 2x squared. Minus 3x plus 1. Now, that means another factor of this polynomial is going to be 2x squared minus 3x plus 1. But remember, the question was to figure out whether or not x minus 1 was a factor also. So what we're going to do is try this negative 1 and see if it's a factor of this. X minus 1 is a factor of this. What do I do if I'm going to use synthetic division?
Positive one.
Put a positive 1, I'm going to do it up here. Put a 1 here, do your big old L, but this time we're going to see if it goes in here. Because this is a factor of this original polynomial too. So I put a 1 here, then I write down a 2 and a negative 3 and a positive 1. Bring the 2 down. 1 times 2 is 2. Negative 3 plus 2 is negative 1. 1 times negative 1 is negative 1. Add them together, you get 0. So is 1 a factor?
Yeah.
Yes. All right. Leaving me then with, now this is what we divided it into, 2x squared. So my answer is 2x minus 1. Another linear factor. So we have 2x minus 1. We have x plus 2 that we started with, and we have x minus 1 that we started with. So the complete factorization of this is going to be x plus 2 times x minus 1, and then our final factor is 2x minus 1. This right here would be called the complete factorization. I think you're going to have to do that today. It's going to ask for the complete factorization. But if I took it a step further and asked you to tell me the zeros are what? Negative 2, we'd say negative 2 comma 0. This one would be 1 comma 0. And then 2x minus 1 would be, now remember you go to the side, you put it equal to 0, solve for x. Add 1 to each side. 2x is equal to 1. You divide both sides by 2. You get a half. So the last 0 is 1/2 comma 0. So today, synthetic division, easy. But then it's all the other little things that you're gonna have to figure out as you go using some synthetic division.